Hello and welcome to another Orange Coast College mathematics video. In this video, we're going to learn to factor sums and differences of cubes. Let's get started. Now, sums and differences of cubes are relatively straightforward. They rely on understanding the following two formulas. When I have a difference of cubes, a cubed minus b cubed, it will factor into a binomial, a minus b, times a trinomial, a squared plus ab plus b squared. All right? Similarly, a sum of two cubes, a cubed plus b cubed, factors into a binomial, a plus b, times a trinomial, a squared minus ab plus b squared. Now, in both cases, note where the signs match, right? When we have a difference, the binomial signs match, right? A cubed minus b cubed, a minus b. A cubed plus b cubed, a plus b. And where they differ, right? Here we have the difference of cubes. You're going to have a positive sign for the ab. When you have a sum of cubes, you're going to have a negative sign for the ab. All right, let's look at the steps to factoring a sum or difference of cubes. Step one is the same always. Factor out the greatest common factor. Check for any common factors amongst all of your terms. Once you've done that, you're going to have a resulting binomial. Is it a perfect cube? If so, step two, write both terms as cubes. Okay, so you may already have an x cubed, but if, for example, you had a 27, 27 is 3 cubed, so write 27 as 3 cubed. And then you simply factor using the formulas on the previous slide we had. All right, step four, if you feel like it, check your work. Always a good idea on tests and things. Let's start with a simple example. So first step, are there any common factors between our two terms, a cubed and 64? The answer is no. All right, next step, identify, do we have two cubes? A cubed is clearly a cube, 64 is 4 cubed. So we will rewrite a cubed minus 64 as a cubed minus 4 cubed. And now we have a difference of cubes, so we use the formula that we had earlier. This will be a minus b, right? So in this case, it'll be a minus 4 times a squared. Remember, now the sign for a difference will be opposite of this sign. So it'll be a times b. In this case, that's going to be plus 4a, and then plus b cubed. In this case, b is 4, so it's going to be, or sorry, b squared, so it'll be 16. And that's it. Some of you might ask, can this be factored? And the answer is no. Let's look at another example. All right, the first step here, again, are there any common factors between these two terms? And the answer is no. 27 is 3 cubed, and 125 is 5 cubed. So they don't have any factors in common, no b in common, no c in common. All right, so the next step, identify each term as a cube. So like, as I said, 27 is 3 cubed. So you could write this as 3 cubed times b cubed plus 125 is 5 cubed times c cubed. And since you have each factor in each term, right, both factors here are both cubes, and same for the second term, you can regroup this using properties of exponents as 3b cubed plus 5c cubed. And now you've written each term as a perfect cube. The only thing that remains is to use the formula. So it's going to be the sum of each number being cubed. So it'll be 3b plus 5c, and then it's going to be the first term squared. It's going to be 3b quantity squared. Then the sign here will be the opposite of this sign. So we get minus, then the product of each of the two terms being cubed, so 3b times 5c, and then finally plus this term squared. Okay, the last thing to do, let's just simplify this. So we get 3b plus 5c times, it's going to be 9b squared if we simply square both factors, minus 15bc plus 25c squared. And that's it. Let's do one final example. All right, first with these two terms, 16x to the fourth minus 2x, we notice we have a common factor of 2x. So we start by factoring that out. We factor out 2x, and from the first term left over, we'll have a factor of 8. and a factor of x cubed. From the second term, we will have a 1 left over. All right, now we look at our remaining binomial here, and we can identify these terms as perfect cubes. And since 8 is 2 cubed, and 1, of course, is 1 cubed, we can't. So this will be 2x times 2 cubed times x cubed minus 1 cubed. And then, again, 2 cubed x cubed can be rewritten as 2x, so times 2x quantity cubed minus 1 cubed. And now we have a difference of cubes. So we go back to the formula. We'll get 2x times 2x minus 1 times 2x quantity squared plus 2x times 1 plus 1 squared. And now just simplify. So we have 2x times 2x minus 1 times 4x squared plus 2x plus 1. And that's it. Notice that, again, this sign here is the opposite of this sign here. Okay. And that's all for factoring sums and differences of cubes. The most challenging part is just recognizing when you have a difference of cubes or a sum of cubes. So practice this material, and I'm sure you'll get it in no time. All right, until next time, have fun.